Have you been lacking money in party invitations because you took ES50? Well, we know we have, and we have the solution for you. With our new air guitar gloves, you can busk for money and fame on the subway or street side without risking damage to a delicate instrument. Our product allows you to wow crowds by playing a guitar from the palm of your hands. For our ES50 project, we set out to make wireless gloves that would allow us to mimic playing a guitar. One of our fundamental goals was to make the system completely contained on the body and avoid having to plug into a computer or speaker.
On a high level, we wanted our air guitar to be as easy to pick up by an actual guitar or bass player as possible. Constrained by our 4 sensors on the right hand, pressure sensors, we decided to adopt a bass's E, A, D, G string structure. On the left hand, meanwhile, we have a flex sensor and a soft potentiometer. The soft potentiometer represents fret shifts, and the flex sensor represents regular shifts.
So the way that our air guitar works is that there are 4 pressure sensors on the right hand that correspond to the 4 strings of a bass. And so you've got E, A, D, and G. And you can push multiple of these down at the same time to play chords. Then on our left hand, there's a linear soft potentiometer that corresponds to the different frets on a guitar. So you've got 0 fret, 1st fret, 2nd fret, 3rd fret, and 4th fret. And then on the thumb, there's a flex sensor, where if you flex it, this will shift the frets to 5, 6, 7, 8, and 9. But even without shifting, you can play a full chromatic chord.
On a more detailed level, each of our sensors is connected to a voltage divider circuit. The 3.3 volt pin on the Arduino supplies voltage across a 10 kilo ohm resistor in series with a force-sensitive resistor. We used most of our 10 kilo ohm resistors to make sure that our circuit didn't short if the force-sensitive resistors had a low resistance when they were unflexed. Using the analog pins of the Arduino, we read the voltage across the force-sensitive resistor in order to measure the resistance. The more resistance we measured, the more our sensors were pushed, flexed, or pressed. Since the resistance increased as we pushed, flexed, and pressed, this would allow the Arduino to detect our notes.
Of course, we ran into multiple challenges while attempting to design our project. Our initial idea was to transmit signal from the Maker 0 to the Maker Wi-Fi 1010 using a radio frequency module, and then send the processed signal to a Bluetooth speaker using the Bluetooth capability of the Wi-Fi 1010. However, the low-energy Bluetooth of the Maker Wi-Fi 1010 proved to be unsuited for sending audio, so it had to be discarded. Luckily, the Wi-Fi 1010 also came with Wi-Fi capabilities, so we switched to using a WebSocket to communicate from the Arduino to a processing script on our laptop, which would process the signal and play the notes. However, even though we were able to transmit signals wirelessly, the RF transmitters ended up being too noisy to actually use. As such, we switched to manually wiring the Arduino's digital pins together in order to send binary signals between them. In a stroke of good luck, this also helped with sending power.